Hey everybody, so we're going to be talking about quadratic functions today. Quadratic functions, they're essentially polynomials that we end up graphing. So these are just the basics, kind of some vocabulary that you're going to hear for the rest of your math careers, and you guys can hear the pitter-patter of my puppies there, but that's okay. You guys can enjoy. So quadratic functions, and that's quadratic. The parent function is y equals x squared. You'll remember that the linear parent function was y equals x. This is the second parent function that we are learning about. And there's going to be a third one before you leave Algebra 1. And those are your three basic parent functions you're going to start off Algebra 2 and Geometry with. Now, just like there's a standard form for linear functions, which was ax plus by equals c, for quadratic functions, it's a little bit different. You work with the trinomial. And it becomes y equals ax squared plus bx plus c. And another way that you can see it is that instead of this y, you'll see it as an f of x equals ax squared plus bx plus c. You'll want to remember that f of x just means function of x. If you need me to write that down. Right. Now, a quadratic function forms a parabola, and you're gonna need to know how to say this word. It's parabola. It looks like parabola, like Ebola, but we're just gonna do parabola. If you say parabola, I do not know who you are. I will not claim you. Now, a parabola is a curve with rays or arms. You'll remember that a ray is a line, okay? It's an arrow, but only one side has arrows. Lines, of course, have arrows on both ends. Now, a parabola is a curve with rays or arms that extend forever upward if the a value is positive, or negative sorry, try to set off my alarm and I got this. Or downward if your a value is negative. And something that ends up helping me when I'm writing upward and downward, if your a value is positive, then yeah, that makes sense that it's going to be positive. But right here, upward, it makes that parabola and it reminds us that it's going to open up. And then we know it's going to open down because of the n and downward and negative. So it opens something like this. Now, the vertex is either the highest or lowest point on a parabola. This can be either your maximum or a minimum. So the reason why, okay, that you're thinking, oh, when would it be a maximum? It would be with the upward. But that's wrong. When you draw something upward, when your a value is positive, right here, the vertex is actually all the way down there, which is your lowest point. Nothing can be lower than this vertex. Think about your happy face and frowny faces. There's the lowest point of a smiley face. But you can always keep getting happier and happier and happier. Now, when your a value is negative, your parabola actually looks this way and looks like a frowny face, and your vertex is all the way up here. And this is your maximum. Sorry guys, you hear my puppies playing now. This is every morning in Miss Sanji's household. So here's some basics that we're going to be talking about today. We're going to go ahead and open it up. And there are about a couple more things that we're going to be talking about. Now the first thing is the axis of symmetry. This is a vertical line. Remember, vertical is up and down. That passes through the vertex. So if I have something that's either opening upwards, it's going right through the middle through my vertex. It's as if I could fold that parabola in half and it would be the exact same because it's symmetrical. That's symmetry. If it were opening downwards, it'd be the same thing. Vertex is here and you've got your dotted line going through. Your axis of symmetry would look like this. You're trying to figure out, what it is or whatnot. Your vertical line, remember this axis of symmetry, they always start with x equals because no calculator, no slope, no function. We're going to start it off with x equals. We're used to using y equals, but instead we're going to do x equals for this again because it's a vertical line. They only have an x in the equation. And the formula is going to be using our standard form. And you're going to be using those a values and those b values and even those c values in the future to kind of fill in those blanks. I could give you any equation and you could figure out the axis of symmetry. All right, so negative b over 2a is the formula for finding the axis of symmetry. There is a way to find the vertex, and that's just when you take this number right here and plug it in to your equation. So you would have to drop this in to your f of x, or whatever your function is. And you would need to drop that in so you can get your y value, and you can actually have a coordinate point for your vertex. All right, now that's a lot, and we are going to go ahead and go over this next time as well. But for now, I want you to be able to at least look at a graph and be like, well, oh, right here, this would be our axis of symmetry. Okay, so something that you're going to notice, there are 4 different spots here pointing to these things here. These actually come from the factors that we've been working with on polynomials. These are called zeros or roots of a quadratic function, and they are the solutions, which we've heard before. They're the points where the graph crosses the x-axis, which means these are our x-intercepts. Guess what? All 4 of these words mean the same thing. So something that helps me remember this is zebras are extra stylish. So you've got zeros, roots, x-intercepts, solutions. That will help you remember these 4 words because I will use any of these 4 words and you should be able to tell me, oh, it's the same stuff. Now your y-intercept can be found if you set x equal to 0. Or the really easy thing that you have, let me move this back down. The really easy step, it's your c value. So you can literally just look at the standard form of a function, whatever number is here, that's your y-intercept, and you would write it as 0, comma, whatever your C value is. And something that you want to notice, the domain of your parent function. Remember, that's y equals x squared. Is all real numbers. That's the symbol for it, and it means all real numbers. You can also write it out if you need to. Before I let you loose, because I'm going to have you fill this in and check your answers on a Google Doc. Right here, this is your axis of symmetry. And remember, we're going to start it off with x equals. You just look at your x value here and you know it's x equals 1. If we were to look at it on this one, we're going to draw our axis of symmetry. So we count 1, 2, 3, 4. And because we're going to the left, that's negative. You've got x equals -4 for this axis of symmetry. So I want you to kind of fill these words in. And then go ahead and check back with me. It will kind of help you out if you need to. So check in with me once you're done with this and you've got some other things to do. Thanks for watching.